Alright, so we'll start with this one. And this one asks us both to find the equivalent resistance and to then determine each of the voltages across them. So, in the way we've been approaching, I'm kind of a hybrid problem. That'll be good. It'll let us practice all of our different skills. So, for the determine the equivalent resistance, you don't really have to do the plot or anything, but to determine the voltages, you would need to. So I'm going to draw this first without the battery so I can do the equivalent resistance, and then I'll draw it again with the battery so that I can do my currents and everything like that. Alright, so remember, excuse the crudeness of my drawing. Very hard to do perfectly straight lines and such on the board. So there's our without the battery, and let's see, what do we have? We have 840, 660, and 470. 840 ohms, 660 ohms, and 470, and 470, and 12. Look at that. Alright, so for doing the equivalent resistance, I would need to do that. And then, are any of those resistors in series or parallel with each other? Are any two or three in any arrangement? The 840 and the 660 are in parallel, so we can combine those two. And so you get equivalent resistance. We'll call it, I don't know, R. And then that would mean, so we combine those. You'd have a single resistor like that. And now, what are those two in? This is still for Those two are in series. So then we can combine those two into a single resistor. We'll call it RF. And that would be that single resistor. So mathematically, to combine those two, I use 1 over R total is 1 over R1 plus 1 over R2 plus plus 1 over Rn. And so I'm looking for R. I have 840 ohms plus 1 over 660 ohms. And so I figure out from that what R is. Right? And then to do the green one, I'm trying to leave myself room here so I don't interfere with my plot. I use that R total is R1 plus R2 plus plus Rn. That's for my equation sheet. So my RF would equal my R plus 470 ohms, and then I'd figure out what RF is. Right? Yep. Yep. And that's the first half of this one. Remember, the Y for that is just those drawings. Now for the second half, maybe I'll just add blue in here. I'd have that same circuit diagram, except I need my battery in there, which is 12 volts this way. So, and I would look at that and say, oh, I have, actually, let me just copy that down here. recopied my diagram so that I can do my currents. Sure. How far up? Mind if I go ahead and do my currents? All right. So I'm going to have, I have two junctions here. I'm going to have three currents. So I'm going to call the one that goes around this way I1. I think there's going to be, call that I2 that goes around that way. And then we'd have, through this way, we'd have I3. Right? So, let me do my plot. Let's see. Battery. Resistor. 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 Yeah, remember, the point of the plot is that it's usable, right? So, yeah, best of my artistic ability there. And let's see. So, I'm going to say that all of this is at that 12 volts. Oh, that's what I forgot over there. Apologize. This is, I should have labeled this 12 volts. And then back right before we get to the batteries at 0, so this has to be a little, this can't be 0 back here, it has to be higher than 0. We'll just pick some intermediate height. And then, so I know all of this is 0 here, then it jumps up, and then it stays at that voltage until it comes to the resistors. And then it drops down some. And then it stays at that constant voltage all the way around here. And it drops down the last bit. Oh, so these two, oh, they're in parallel. So they're going to have the same voltages, right? Change across them. So let's see, I know this slope will be 12. This slope here would be 470 I1. This one out here would be 840 I2. And this one in here, trying to figure out the best way to lay it, but 660 I3. So that would be an acceptable full credit plot. So I have two junctions. How many junction equations will I get? One. How many loops around the circuit? 3. Now I really only have to find 2 of them, right? Because I only really need 3 equations if I have 3 currents, if I have 3 unknowns. But I just have to make sure I find the 2 that involve all of the currents. So it might be just easier to find all 3. Because I've got a big outside loop, I've got a loop that goes around the right-hand part, and a loop that goes around the left-hand part. And that would give me all 3, and my one junction. So, pull this up here. My junction, I'm going to do the bottom junction here, so I'd have I1 equals I2 plus I3. Because I1 heads towards that point, I2 and I3 head away from it. Then, go to my loops. I'm going to do the left-hand loop. Starting in the bottom left corner, I'd have negative 840 I2, go across, go up, so plus 660 I3 equals 0. Then I'm going to do the right-hand loop. And I'll start at the bottom right corner and go counterclockwise. So negative, positive 4. I'm going to start at that point. I'm going to go clockwise though. I went clockwise last time. So starting at the bottom right corner, clockwise, I go 12. So I go up to 12, down the 660 I3, around the corner, down the 470 I1, and back to where I started. And that's that left-hand one. And actually, I could stop at that point because in my current equations, I have all of the currents. In my loop equations, in my junction equations, in my loop equations, I have all of the currents. I'm going to do that last big outside one, but technically I don't really need to do it. But I'll start at the bottom left corner where I started here. I'll do 12, keep going across the bottom, go up the left side, and then so minus 840 I2, across the top down, minus 470 I1 equals 0. So technically I only need the top 3 of those, but if I use all 4, I can also find it. So, Jen, I'm going to need to get up my computer in just a second to be able to use it. So which solver do you guys think? Why don't you guys try it for a second, and then if you hit any glitches, let me know, and I'll try it also. It's kind of a mixture of solvers. Let's see, which solver do I feel like using? Anyone have a preference on which one I use? You want the purple one? Or a third solver? You like the purple one? I've kind of been leaning more late in the last couple of classes towards the other one, actually. Absolutely. Alright, so I get this thing. So my currents, I'm going to use ABC, but A equals B plus C, my currents, and then I have 8. There we go. And I have negative 840 B plus 660 C equals 0. And then 12 minus 660 C minus 470 A. If you haven't tried using the solvers, I would strongly suggest putting in your numbers and give it a whirl, because on the test you are going to need to be able to solve the math parts of these. So I found that the more you practice putting them in, the better you get at it, and and by better I mean the less mistakes you make. And yeah, I got answers. So as a couple people have brought up, we have just found the currents for this, but the question did not ask you for the currents, it asked you for the voltages. So once you have your currents, then you need to go back and say, okay, well, I understand that I have my currents now, I1, I2, and I3, and what it asked me for was the voltage across the 840. Well, I'm going to use Ohm's law. V equals IR. And I have the current, I have the resistance, and I'm going to use that to find my voltages. Alright? So remember, we're using Kirchhoff's Kirchhoff's laws, rules, to find the currents, that doesn't mean that that's what they wanted to do. Now on the test, the question will be like it was on the example problems. Find all of the voltages and all of the currents. So